In the first part of this example, we're asked to first of all plot these points, which are given in polar coordinate form, and then also to convert polar to Cartesian coordinates. So let's actually start by plotting the points. Now remember, when you're looking at a point in polar coordinates, the first coordinate represents the r, or the radius value. That is how far away you are from the pole along a radial line. And then the second value represents theta, which is your angle from this polar axis here, going clockwise if theta is positive. So let's start with our angle. Our angle here is 2 pi over 3. So let's see if we can figure out where that is. Hopefully you remember where that is. You can think about the unit circle. 2 pi over 3 is in this second quadrant here, and it's on my little plane here. It's represented by this line right here. So this angle here is 2 pi over 3. So we know we're going to be at that angle, and then this r tells us that we should be 3 units away from the pole radially. So it looks like then, on my picture here, I should be right here. And this would be the point 3, 2 pi over 3. Now while we're here, we'll go ahead and plot our second point as well. And that was negative 4 pi. So once again, let's start by thinking about the angle. We have an angle of pi here. So pi radians from the polar axis here. So that's the same as 180 degrees. So it should be over here. Now let's actually start by plotting the point 4 pi. Just because I want to make a point. So if I were asked to plot the point 4 pi, I would be here at an angle of pi, and then I'd be 4 units away from the pole here. So here would be 4 pi. But I'm asked to plot negative 4 pi. Basically what that is, negative 4 pi, the fact that the radius is negative, it's just going to mean I'm going to be reflecting through the pole. So then negative 4 pi is going to be along this same line here, but on the opposite side of the pole. So over here is my point, negative 4 comma pi. So now that we've practiced plotting these points on the polar coordinate system, let's now practice converting them to Cartesian coordinates, and then we'll actually be able to check ourselves by looking at our graph again. So let's then start with our point 3, 2 pi over 3. Now we have some formulas that allow us to convert from polar coordinates to Cartesian coordinates. And those are that x equals r cosine of theta and y equals r sine of theta. So those are pretty straightforward to apply in this case. So my x value then, my x coordinate is going to be r, which is 3, times cosine of 2 pi over 3. So we need to know what the cosine of 2 pi over 3 is. And that is negative 1/2. So we have 3 times negative 1/2, or negative 3/2. And then y is going to be 3 sine of 2 pi over 3. The sine of 2 pi over 3 is root 3 over 2. So we end up then with 3 root 3 over 2. Okay, so then my final answer, which is just going to be this point in Cartesian coordinates, is negative 3/2 and then 3 root 3 over 2. Now it would be hard for us to check this exactly if we wanted to see if it agreed with where we plotted our point in polar coordinates, just because these values are kind of nasty. But we can at least note that this is in the second quadrant, right? Because my x value is negative and my y value is positive. Right, so I know this is in the second quadrant, and that at least agrees with what we had before. Right, we had this point here in the second quadrant. So let's look at part B now. Now we're looking at the point -4 pi, and we're going to convert that to Cartesian. We can use the same formulas. So I'm going to use x equals our cosine theta, which in my case is -4 times cosine of pi. Cosine of pi is -1, so I get -4 times -1, which gives me 4 in the end. And then to find my y-coordinate, I'm going to do our sine of theta. That gives me -4 times sine of pi. But sine of pi is 0, so this is -4 times 0, or 0. So then I end up with the point +4, 0. So that's pretty easy to check. If we go back and look at what we graphed before, here was our point in polar coordinates, -4 pi, and it definitely looks like that agrees with the Cartesian coordinates 4, 0. Now let's look at the second part of the question, where we're asked to do something a little bit different. Convert Cartesian coordinates to polar coordinates. And so we have the Cartesian point to -2, and we can start just by realizing what quadrant that's in. That just might give us a little bit of insight when we're thinking about converting from Cartesian to polar. So 2, -2 is going to be somewhere down here in the fourth quadrant. All right, so how do we convert from Cartesian to polar coordinates? Well, just like before, we have a few formulas that are going to help us do that. So we have this equation, r squared equals x squared plus y squared, and then also tangent of theta equals y over x. So let's go ahead then and apply those formulas to our Cartesian point here to -2. So first of all, I'm going to use r squared equals x squared plus y squared. So I get r squared equals 2 squared plus -2 squared. So then I have r squared is 4 plus 4, or 8. So that's going to give me r equals plus or minus the square root of 8. We'll leave that for a minute, and then in just a few minutes we'll talk about which is appropriate here, the positive or the negative root. But let's go ahead and do the second formula as well. So tangent of theta equals y over x. So I know then that tangent of theta is -2 over 2, or that tangent of theta is -1. So we need to ask ourselves, what are the theta values where the tangent is -1? Well, if you recall, the tangent is the sine over the cosine. So then what I'm looking for are places on the unit circle where the sine and the cosine have the same value but not the same sign. So we know that should happen then in the second and the fourth quadrant at the pi over 4 reference angles. So one way I could write that then is at theta equals -pi over 4, or you could also write that angle as 7 pi over 4. Or the corresponding angle here in the second quadrant, where theta is 3 pi over 4. So if you know anything about the unit circle, you know there are several ways we can describe this angle, or these angles, these two angles here. So I'm just going to say here that this is true when theta equals -pi over 4 plus k pi. So -pi over 4, which is here, but then also any half rotation around the unit circle is going to get us back to a point that also has a tangent of -1, and of course we can go infinitely many times around. So there are an infinite number of angles where the tangent is -1. So then maybe, or hopefully what you're starting to realize is that for any given point in a polar coordinate system, there are really infinitely many ways to describe that point, and because of the way these angles work. All right, so let's try and formulate some sort of final answer here. Let's go back then and think about this radius for a second. When we solved for the radius, we got that r could be plus or minus the square root of 8. And actually, we're going to be able to use both of these solutions. Let's first think about describing this point with an r equals positive root 8. So remember, keep in mind that my point here is in the fourth quadrant. So let's actually make this picture a little bit bigger. So here is our Cartesian coordinate 2, negative 2 approximately. So if we want to use this positive r value, then we're going to want to use this angle negative pi over 4. But because I can go a full rotation around the circle and get back to the same point, I want to include here negative pi over 4 plus 2k pi. And note that I could go around the circle in either direction here and get back to the same point. So k just represents any integer. But what if we wanted to use r equals negative root 8? Well, we still want to end up at the same point here. So if we're going to use r equals negative root 8, what we need to do is we need to come from a reflection on the opposite side of the pole here. And over here, the angle we could describe as theta equals 3 pi over 4. So then, if we want to use r equals negative root 8, we would just need to use theta equals 3 pi over 4, or once again, any multiple of that as far as rotations around the unit circle. So what we see here then is that it's a bit more complicated to go from Cartesian to polar, but keeping in mind what quadrant you want to be in, and then also the fact that there are many different ways to represent the same point in polar coordinates should help you out.